Okay, so welcome back to today's lesson. So today we are going to be looking at understanding Alkane Ii. In the first part of this Alkane discussion, we were able to look at what the Alkanes family are. We were able to look at the homologous series, the functional group, the alkyl group, and also nomenclature of alkanes. So if you have not seen that video, you can search for Fairness online class and look for videos under understanding alkanes. So today we want to look deep into another part of the alkanes, talking about the preparation, properties, environmental effects, and uses of alkanes. So now basically we'll be looking at one of the methods we can use to prepare alkanes. Generally, what the method used for preparing the alkanes, each member of the alkane, for instance the methane, the ethane, the propane, is the same actually. What differs is just the type of salts used. Okay, so now let's take a look at what we have there. Alkanes can be prepared by reacting sodium ethanoate with soda lime. So we are talking about laboratory preparation here now. Now, example, ethane can be prepared by hydrogenating ethene. Ethane. What we have here is ethane. So we have been able to produce ethane. We have been able to produce ethane from ethane by hydrogenation. So for the one that has to do with sodium ethanoate with soda lime, we can have this schematic illustration here. Now if we look at this, you will see that we have the sodium ethanoate combining with soda lime in a test tube, and it's being heated. So upon heating, the gas. So let's look at the chemical properties of alkanes. They are generally unreactive. They undergo combustion to produce CO2 and water. Now when we are saying combustion has to do with the ability of the substance to burn in air, to burn in the presence of air. So alkanes generally, they have the ability to burn in air, and that's why they can be used as fuel. Even the gas we use at home, the one we use for cooking, is actually an alkane. Okay, but now there's this effect of when you burn something, you can either have complete combustion or incomplete combustion. Now when you have a complete combustion, it's going to result to production of CO2, which is carbon dioxide. Now the good part of it is that if we have carbon dioxide in our environment, and we have plants, the plants will make use of this carbon dioxide to produce their own food. So in other words, the plants, once they produce their own food, they end up releasing oxygen to the environment. We will consume the oxygen. So now what is the effect of this in particular? Simply means combustion of alkanes will bring about release of CO2. Basically, complete combustion will bring about the release of CO2 to the environment. Now, if we have a green environment, what do I mean by green environment? The plants. So this plant will absorb the CO2, thereby balancing the amount of CO2 in the environment. So that's why tree planting should be encouraged in our society, because many people now, they actually burn one substance or the other, and this contributes CO2 to the atmosphere. Now this excess of CO2 can be have a negative effect when it's too much in the atmosphere, but when we have plants, trees around, they absorb this CO2 to make their own food, and in turn give out oxygen which we can breathe in. So with that, the gas will be balanced. Okay, but when we are having complete combustion, we can have what we call production of CO, which is carbon monoxide. Carbon monoxide is a toxic gas. So that's why it's very, very important for us to ensure that any fuel we are using can actually undergo a complete combustion. So they can also undergo substitution reactions. Alkanes can undergo substitution reaction. Alkanes react with halogen in the presence of UV light. Now this is a chemical illustration, the chemical equation for the combustion of alkane. This is methane, as you can see here, combining with oxygen to produce CO2, then water. Usually the end product of combustion of alkane is usually CO2 and water. So now we also have this for the substitution reaction of alkanes. So if you look at this states the reaction occur in 4 stages actually. In the first stage, what can you say in the first stage? In the first stage, you will see that this methane rather, the methane combined with chlorine gas in the presence of UV from the sun. So when we mean substitution reaction, and for instance in football, if they say substitution reaction, one person will have to go out for another person to come in. So if we are saying substitution reaction, hydrogen in this case we have to come out, then chlorine will replace it. So one hydrogen is coming out, so that's why you are saying that it's being reduced to CH3 and chlorine is being attached to it. Now the hydrogen that is being removed here combined with the remaining chlorine to form HCl. So this is chloromethane. Now in the second stage, this chloromethane then combined with another chlorine gas again, and the process continue where we have dichloromethane and HCl produced. In the third stage, we have this dichloromethane combining with another chlorine gas to form trichloromethane. The trichloromethane again combined with another chlorine gas to form tetrachloromethane. So all this is actually a substitution reaction. So very quickly, I need you to pause this video and try to practice on your own the chemical equation for combustion of alkane and also substitution reaction in the presence of chlorine and ultraviolet light. So when we are talking about halogen here, we are actually talking about the chlorine. Okay, here comes a critical thinking question under functional group. Compare the reactivity of alkanes with alcohol. Compare the reactivity of alkanes with alcohol. For you to answer this, you must have seen the first video on understanding alkanes. So pause the video and quickly do the activity. Second question is discuss why functional group affects reactivity. So you are free to discuss your answer with your class. You are free to share knowledge together, and if you are studying this on your own, you can just get your book, pen down your response, then thereafter you check the response from this video. Okay, so here we have the response for the first question and response for the second question. Physical properties of alkanes. Alkanes are non-polar molecules. They have low boiling and melting points. Boiling point increase with molecular size. So it simply means as the number of carbon increases, the boiling point also increases. Uses of alkanes. Alkanes are used as fuel, e.g. methane, propane. Now, did you know that even there's something we call biogas? That's why basically now nothing is totally a waste. For instance, the cow dung can actually be used to generate domestic gas we use for cooking. If you get a cow dung and you have a biodigester or what we call a bioreactor, it can be used to convert the biogas and the cow dung to methane that can be used to as domestic cooking gas. They are also used as solvents. For example, butane is used in lighters. Environmental impacts of alkanes. Combustion of alkanes releases CO2, a greenhouse gas. We've talked about this earlier on. Incomplete combustion produces CO, which is a toxic gas. Discuss ways to reduce the environmental impact. Okay, this is an activity for you. Quickly pause this video. Think of a way that we can reduce the environmental impact of the use of alkanes. Okay, this is another activity, reducing environmental impact. In groups, brainstorm method to reduce the environmental impact of alkane use. Create a poster to present your ideas. Now, basically, this activity is a collaboration effort that can bring about results here. So basically, this can actually be done as a class. Maybe if you are a school and your student, they are watching this video, so they can actually do this activity as a way to give back to the society. Like, it's just like telling the society about the effects of using alkane or any of the products of the alkane the environment. Okay, we have the final assessments. What is the general formula for alkanes? Name the alkanes with the formula C4H10. Describe the method of preparing alkanes. Differentiate between homologous series, alkane group, and functional group. Explain the difference between complete and incomplete composition. So our closing thoughts and questions. Any question about today's lesson, you can put your thoughts down in the comment section as well. How do you think alkanes impact our daily lives? What was the most interesting thing you learned today? Lesson, bye. See you some other time.